Welcome everyone, welcome to Hong Kong. This might not be the most iconic view of the city, but today I wanted to talk about CO2 and how it is implemented in our Ambient16. CO2 is one of the 16 senses of our smart home sensor. The reason why we are here under the bridgeway in the harbor is because you have quite a high traffic up there, and high traffic means CO2. And a lot of CO2 sensors cannot measure pollution because they are using so-called CO2 equivalent. CO2 equivalent is about measuring the H2, the hydrogen coming out of our breath. It is coming from digestion of humans. But CO2 equivalent is not measuring plants, animals, and moreover, pollution coming from the traffic up there. Here, a CO2 equivalent system would say, good air, and believe me, it's not fresh air here. So this is our office, this is where we live, this is where we have built this sensor, and now we are going up in the skyscraper up there in our lab, and we will see how we have exactly set CO2 inside this little box. Welcome back to our lab. This is where we make all our sensors. For CO2 we use that kind of machine. This is a climate chamber with temperature, humidity, and we have modified it with gas addition here for CO2, nitrogen, fresh air, and this is how we qualify all our sensors. Before talking about how to detect CO2 molecules, we should talk about the molecule itself. It is made of one carbon atom and two oxygen atoms. This is generally the way you depict it at school. In fact, it is highly vibrating, and as in any vibrating system, you have so-called resonance frequencies. I take apart the molecule so that you can see the electromagnetic bindings between the atoms. And this binding here has a very specific resonance frequency of 4.26 micrometer. So if you put a light with that exact wavelength of 4.26 micrometer, it will have the right energy and will excite even more the binding between the carbon and the oxygen atoms. And this light will be absorbed. So that if you use another light with another wavelength, a little higher or a little lower, it will just pass through. So what we're doing actually for measuring CO2 is seeing how much light at 4.26 micrometer is absorbed by CO2 molecules. So the first thing we need for our little experiment is a heat source. And the best heat source you can find, the cheapest one, is a light bulb. Exactly like the light bulbs we had in our homes, they are incandescent light bulbs. They have vanished because they were too energy greedy, and indeed they are emitting a lot of heat. You could not touch them, and this is why they are energy consuming. We could not use a LED because an LED has a very, very narrow emission of light. This is why they are very energy saving. Of course, we have not put a bulb like that in a 5x5 square with all the sensors inside. We are using a very, very tiny version of it. I'm not sure you can see it. Well, actually, it is exactly the kind of lamp I was using in my model trains as a kid. So we have that inside. The next element we need in our setup is a way of detecting infrared. So I first thought I'd put a standard camera as a light detector. But in fact, I will use a thermometer because this is exactly what we're doing. We are measuring temperature, 4.26 micrometers, this is infrared, this is heat. And we are well acquainted now with the thermometers everywhere in these times of COVID. And indeed, we are using exactly the same kind of components, very small one. I'm not sure you can see it, but this is exactly the same kind of sensor used in this thermometer to measure the temperature in your forehead. So we have that as well inside our sensor. But there is still one element missing. It is a color filter, because the sensor will see all the ray of light coming from the bulb. So you need to add a color filter in front of the light detector so that only the 4.26 micrometer wavelength goes through. And voila, it's finished. If you have some CO2 molecules between the bulb and the filter, then light will be attenuated. And this is what we are actually measuring on our heat detector. This is how we detect CO2. Actually, we are talking about attenuation between 1 and 2%. This is very, very tiny. And adding a CO2 sensor beside the 15 other sensors in our cube has been a real challenge. You require special electronics for low noise, special materials for reflectivity, for filtering, and also for letting the CO2 molecules go through. There is nothing to be seen here. It's measuring through the square. And as well, we wanted our sensors to be very practical to use. Compared to other sensors, ours are factory calibrated in such machine. Other sensors require so-called fresh air calibration. They are required to be put outside during 1 hour every week or every 2 weeks, like laundry, to recalibrate. Ours don't do that. I will explain how we do that in other videos. So I propose we now go and see the thing in operation. So Thibaut is here, the master of CO2.
Hi.
And he has his computer, which is on our big screen here. And we have one Ambient16, which is sending data up to our cloud. We are using Influx. It is Influx ready. And we also use Grafana to display the CO2. And Thibaut will simply have a look at the CO2. We see here all values. And it will blow on the sensor.
Yeah,
and we should see the...
I just changed the scale, sorry, and...
And here we are. We have the CO2 scale. CO2 is rising. So here we have approximately 500. It's the morning here in our meeting room. The air has been renewed by air conditioning all day. Outside it has rained. We are in Hong Kong, so we should be around 500. So basically what we have here is fresh air. Well, fresh air, Hong Kong fresh air. And Thibaut has been blowing. Breath is about 10,000 ppm. You've been blowing really only a little on the module, and we see we reach quite a high level here, 1,200 ppm. This is, well, not quite a lot. I mean, this would be roughly the CO2 level in this meeting room with a lot of people. And you see it's very reactive. It has been inside within a few seconds, because of course this front here, the front of the sensor is totally transparent to CO2. I mean, the CO2 goes inside, so it is very, very, very quick. Now the CO2 is inside, and the measure will go down now. So here it is. This is our CO2 measurement. Exact CO2, not only people, plants, animals. We are measuring also pollution, and you see absolutely nothing on our sensors, and the CO2 goes in and factory calibrated. We're very proud of it, because this was a real challenge, actually. So thank you for having had a look to our little video explaining our adventures with sensors in smart home in Hong Kong. Thibaut, want to give another blow?
Yeah, I can give another
a real one.
A real one?
No, that's not a real one. No, not blow. Yeah. Okay. So now we'll have fun with smart home sensors and CO2. Oh yeah. I'm not sure. it was enough.
I can do more.
No,
It's
no, now you are reaching.
Yeah, yes.
Okay, thank you.